When it comes to maintaining the pump itself and going through it, we can go through, I'm going to take apart and go through the check valves and all the individual pieces here. There's an intake and a discharge. Take a look at the two check valves. You can see that there is a difference. This is the intake, this is the discharge here. Chemical coming through the valve body to prise up the poppet around the seal. The chemical comes out, goes up through the pump as we've seen before. When the piston pushes over, it forces the chemical up through the discharge valve, and the discharge valve basically is setting upside down like this. And what happens is chemical going through pushes the little poppet in by the seal, goes up through the valve body, out the chamber, and out to the discharge line. So like I said before, there is a difference. You can get them mixed up. I usually in service tell them, especially if they're not very familiar, tell them to take them out one at a time. Look at each one individually and then put it back. We don't want to get them mixed up. We don't want to put the discharge back in the intake because it'll force against each other. So I'm going to take them both apart here. And if you look right here, there is a little clip that holds the valve body to the neck of the valve itself. And there's a little tab on this clip, and you see that? We always want that facing up. Everything is spring loaded, so be careful when you take these apart. We always recommend taking them apart inside a clear plastic bag. That way you keep everything, parts don't fly all over. Best thing to do, I always found, put your bottom finger on the top of the poppet, and you have to turn it, give it a 90-degree turn. Slowly take it out, and you can see the little clip's gonna come off. It sits on top of the spring. Here's the spring. We can pull the poppet out from the bottom. Here's our parts right here. Now if you look, we got the little clip that goes with it. We've got 3 seals on each check valve. There's the one around the neck of the valve, check valve itself. There's one around the valve body. And then there's one right here on the poppet. Now we saw that the poppets are different, but the O-ring on here is the same for the other poppet as well, even though they're different shape. When you take these out, if you take a look here on the top here, we always recommend use an Allen wrench to put right inside there, either that or like a 3/8 bolt head. Don't take a plier or channel lock pliers and go around the edge to try and turn these out, because you can damage the edge and you'll probably also damage the ability for it to seal, and you're going to get chemical leaking out. That would be the intake valve. I'm going to move the parts over and we'll go to the discharge. Once again, there's a little tab with a clip on there. You can see it better on this one. We take that off. Once again, got to be careful that parts don't fly. Take it off slowly, spring loaded. It's going to look a little different in here. Here's the screen. If you look right at the bottom, right there by my finger, right here, see that little edge there? When you put it together, that sets right on top of the spring. You don't want to put this end on top. You want to put the little spring guide on the bottom that sets right on top of the spring as we set it back in. Everything comes from the bottom up. I'm just going to flip it over. Here we have the little spring and we have the poppet itself. If you take a look at the difference between the two poppets, you can see the difference here. This is the intake, this is the discharge. So they're different, but the O-ring will fit the same. And I want to make one other comparison too when you're taking these apart. There's a difference in the spring size for the intake is wound much tighter than that from the discharge. They are different. That's why I always tell everybody, do them one at a time so you don't get the parts mixed up. Is it complicated? Really not. You can go through these, they're not hard to do. What you want to do is when you're taking them apart and when you service them, check for cracks or in the seals and the O-rings. Are they misshapen around the little poppet valve at all? Are these little poppet? Is it good and round? Are everything good and tight? If we're taking a chemical like N-Serve, we recommend this be done every year, once every year, just because of the makeup of the chemical. Roundup is more forgiving. I've talked to guys who haven't done anything to their pump for 4 years and it works good. Not that we're recommending you can go for 4 years, but it's just the type of the chemical. I've seen these pumps, they can pump all kinds of chemical, thickness, you name it, they can handle it. They won't take the wettable powders with the grit and the sand in there. Those kind of things, you're going to run into issues because you can see how small these parts are. You get a little grit and that kind of stuff on these tips here, on the poppet seals, you're going to have issues that they won't seat back in and get a good seal. But when you're talking N-Serve, because of the nature of it, the corrosive ability of it and how tough it is on parts, what we usually tell people do at the end of the season when you're done with it, flush it out with some kind of fuel oil or kerosene. And if you're going to store it outside for the winter, you can run soapy water through it, but when you're done for the winter, use 50-50 antifreeze, not RV antifreeze. We find that the 50-50 provides a little better lubrication, doesn't gel up as quick, so we always say the 50-50. That's in the manual. Once you're ready to start your season, that's when we take the pump apart, go through those seals, and I would replace them all. If they've had end served the year before, replace and put a whole new set of seals in. We have a seal kit that has all these parts in there, 117-0159-987. That would be our recommendation to do that. I think a lot of times people are afraid to see all these moving parts. What can I do? If you take them and break them down one piece at a time, it's not that tough. You just got to spread it out, keep everything together, and it works pretty good there. Now I'm going to disassemble the physical part of the pump. We have, like I said, there's two identical heads on this pump, the left and the right side. This one, of course, is made with a cutaway so you can see inside there. On each side of the piston, there's two seals here. First would be the O-ring, and that fits directly right into the pump head. The other one is a flat seal, fits right over top of the piston. This is what keeps the chemical from going into the pump head itself. That's called the slipper seal. That's also included in that kit along with this other O-ring right here. If this slipper seal has gone bad, one of the telltale signs to know that is we look on the underside of the pump. It's called a weep hole. If chemical is getting by on that piston, you're going to get chemical running out the bottom of the weep hole. That'll tell you more likely a bad slipper seal. This part here is the bearing, holds the piston in place. These don't wear out very quick. The type of makeup that they are, you know, chemical doesn't bother them. They're much harder plastic, so we're not going to run into an issue. I'm going to backtrack here just quickly on these check valves. They are made out of a component called kynar. It's not plastic. It's a plastic makeup, but it's much more harder and chemical resistant. We used to make them stainless steel. I think one of the reasons we went to the kynar is if someone would deadhead their pump, if you'd try and run the pump and have the valve shut and you're trying to force chemical out of there, you could deadhead the pump and you could actually crack the head of the pump. This way, what usually happens is the valve itself will crush and allow chemical to go through, so it's more of a stop. It's kind of a pick your poison. Either replace one of these things or replace a whole pump head, which is quite a bit more expensive. Like I said, you can crush or turn these things crooked by two ways. Either you deadhead the pump or you over torque it when you're trying to turn them in. You can turn them in too hard and you can crush those valves on there. I'm going to turn it around just to take the other side off. Same thing, this is a complete one. Like was said before, if we look right here, there is an arrow. Tells you which way the pump head on there, the left side on, that goes this way. While we got it apart here, I'm going to take this shuttle out. I'm going to lay it down here, and this is what the shuttle looks like. You have the little ball, we have a magnet on the end, there's a spring in between, and it's exactly the same as the opposite side. What we've done now is we've changed this. Instead of a stainless steel spring in here, we've made it more solid. I think that the original thought was that the spring gave us more of a flex action going back and forth through the shuttle. What we found out over the years, the spring actually loses tension and it causes more of a hindrance than a help. So what we've done is made this spring part here a solid piece. And one other thing is we've made the balls 2/1000th of an inch bigger. The reason we did this, when it works in that channel, we found out when we're trying to calibrate a system at a very low rate with a real thin substance, chemical substance, the water or whatever would actually pass by the balls as it goes through. So we found out that if we made them just a little larger, it catches it. Now I'm going to take the pump body off here. By the way, it's 5/32 for the pump heads, the left and the right, 3/16 for this one, Allen wrench. I'm going to take the piston out and the bearing. You see here the piston, the indent here, fits on the end of the bearing. And as that shaft turns, it rotates, pushes the piston. We get that action of it going back and forth. If we look at the bearing, this is the collar. We've got a couple set screws. This part here is the bearing right on the end. This is an older one. What we've done, that we've used we've made this all stainless steel because we've had some issues of probably chemical getting back in there, probably the slipper seals have worn. Sometimes we talked about before with the anhydrous that it finds its way back into there through the check valves. What we found out is that what we can do is the stainless steel, these bearings have lasted a whole lot longer time. And the final recommendation I'd probably make on here is setting up this bearing. Either use calipers or a feeler gauge before you take the one out. From the facing of the plate of the motor to the front of this collar, not the bearing, we want that to be within a range of 1.045 to 1.050 inches. Obviously, if we get it too close, it's going to bind and not run smoothly. If we get it much more out, it'll still run, but it's going to run, you're going to hear it knock and make a lot of noise. The other thing people ask is on this, do we lubricate things? We've got the little indent here where the bearing sits. Put a little grease in there. I used to say, fill that up with grease. And our engineer said, you do that, you're gonna get grease flying out of your weep hole. That's way too much. Put a small dollop of it, and you can use lithium 2 grease, just regular grease, no big deal. You put that on there, you set it on top of the bearing here, and that'll lubricate things up. It's not that hard, it's just, like I said, take your time, go through it. I think we've had at least 4 generations of pumps going back to the 90s. We still got some of the guys with the original pumps running yet. If you maintain them, they last for years.